Lesson 8-13, Probability. By the end of today's lesson, you will be able to find the theoretical probability of an event and its complement, as well as compare the experimental probability of an event with the theoretical probability. Make sure you have a piece of paper and a pencil ready, and pause the video as you need to as we go along. Probability is a measure of the likelihood of an event. The probability of an event is any number from 0 to 1. A probability of 0 means an event is impossible. A probability of 1 means an event is certain to occur. Let's take a look at this image right here, and it shows between 0 and 1 how likely an event is to happen. So we read that 0, it's impossible. There's no way that this event is going to happen, and 1 means it's certain. So if we get a number somewhere between 0 and 1, we're going to have to figure out if it's more unlikely to occur or likely. So we know that half right here, that's the middle point. So anything below 1/2, you would say it's unlikely to occur, and anything greater than 1/2 would be likely to occur. And anything in between here, as long as it's greater than 0, it's possible that it's going to occur. So when we use a formula to find probability, that's called theoretical probability. And the formula for that would be P(E) equals the number of favorable outcomes over the total number of possible outcomes. The P right here stands for probability and E of the event. So probability of the event equals number of favorable outcomes over the total number of possible outcomes. Let's take a look at this spinner in order to help concrete this idea of theoretical probability. So each number on this spinner, we've got 9, 1, 3, 5, 7. Those are each one possible outcome or result if we were to spin this spinner. The sample space or set of all possible outcomes is 1, 3, 5, 7, or 9. So let's find out the probability, that would be P, of spinning a 2. So we look over here and we see, let's see, the probability of spinning a 2, well, there's not even a 2 on here. So that would be 0 out of, then we count the spaces. There's 1, 2, 3, 4. There's 5 spaces. So the probability of spinning a 2 is 0, because 0 over 5 equals 0. So that would be impossible. There's no way that we would be able to spin a 2. Let's take a look at the probability then of spinning an odd number, any odd number. So we take a look again, and we have, all of those are odd numbers. So there's 5 odd numbers listed out of, that looks like a 15, sorry. There's 5 odd numbers listed out of 5 spaces. 5 over 5 equals 1, so that would be, you're certain to spin an odd number. In the last example, we have the possibility of spinning a 7. So we have one spot here with a 7 on it out of 5. So in decimal form, that would equal 0.2, just 2/10. So that's possible. We may be able to spin a 7. It's possible because it's right there in the middle between 0 and 1. So that's what theoretical probability looks like when we break it down. I know at the beginning here with that formula it seems a little bit scary and abstract, but it's really just figuring out and using a fraction. How many spaces out of the total? So here's the number of spaces that are available out of the total number that there are. So I want you to figure out, what would the probability of landing on 3 be? Go ahead and pause the video and then come back and check your work against mine. So for the probability of a 3, we would have, there's one spot that has a 3 out of 5, so there's 1/5, and in fraction form, that would be 0.2, and that would be possible. Okay, and then what would the probability be of an even number? Okay, the probability of an even number would be, there's 0 even numbers on here out of 5 spaces, so that would be 0, and it's impossible. Okay, I hope that those were the answers you were able to come up with as well. Now let's move on to complementary events and mutually exclusive events. So to have complementary events, that would be when two events, E and not E, are complementary if both events cannot occur at the same time. The sum of their likelihood of occurring is 1, because remember 1 would mean that it's certain to happen. So in order for it to be complementary, working together, E and not E would equal 1. So let's take a look at that with some numbers so that way you can understand this concept way better. Okay, I noticed there was a 1 after the A right here, or sorry, there was an A after the 1 right here that wasn't supposed to be there, so I just took that off. So let's take a look at this formula. If we have the probability of not 7, that equals 1 minus the probability of 7. So now we just need to plug in the numbers. So that would be 1 minus the probability of 7 is 1/5, which equals 1 minus 1/5 would be 4/5. And in decimal form, that equals 0.8, so 8/10. So when you're given the probability and the complementary events, you just plug in the values that they give you into the formula. So let's take a look at mutually exclusive events. When we have two events, A and B, that have no outcomes in common, they're called mutually exclusive or disjoint events. So the formula for that would be P times A or B equals P times A plus P times B. So this will be when we have two totally different events and we just want to see what their combined outcome possibility would be. So if we take a look at this example,